In this presentation, we are going to talk about sensory and motor organization of the nervous system controlling human movements, and we'll be discussing it to 3 different types of audiences. Explaining sensory and motor organization of the nervous system controlling human movements to a 10-year-old child. The nervous system. The nervous system is the highway along which your brain sends and receives information about what is happening in the body and around it. This highway is made up of billions of nerve cells, or neurons, which join together to make nerves. A nerve is a fiber that sends impulses through the body, and nerve cells work by a mixture of chemical and electrical actions. The 2 main parts of the nervous system are the central nervous system, or the CNS, and the peripheral nervous system, or the PNS. As I said, the nervous system is made up of 2 main parts: your central nervous system and the peripheral nervous system. The central nervous system is made of the brain and the spinal cord. The brain is protected inside the skull, and there it controls all the body functions by sending and receiving messages through nerves. Think of your brain as the motherboard of a computer. It will control the computer to do what it needs to do. Now, your peripheral nervous system carries messages to and from the central nervous system, so it's like a 2-way highway. It sends information to the brain and carries out orders from the brain. Messages from the brain branch out to all different parts of your body, whether it's back to the brain to control other parts, whether it's to your ears, eyes, face, or other things, or visit other muscles and organs within your body. Think of the peripheral nervous system as all the wires connecting to the monitor of the computer. Let's break down your peripheral nervous system a little bit more. It is made up of 2 main parts: the somatic nervous system and the autonomic nervous system. The somatic nervous system sends sensory information to the central nervous system through peripheral nerve fibers, which just means nerve coming from your fingers, from your tongue, from your eyes. All of that is gathering information from the world around you, and it's sending it off to the central nervous system to be processed by the brain. Sensory means that it sends information coming from all your senses, as said, and it's going to send it into your brain to be processed, and then the brain's going to determine what to do with that information. The peripheral nervous system also sends messages to the motor nerve fibers to get the muscles to move the body, in response to the sensory information it gets. Now, the autonomic nervous system is responsible for making sure that all the automatic things that our body needs to do to keep you going continues working smoothly without you having to think about it, such as breathing, digesting food, heart beating, and all that other stuff. Because just imagine how hard it would be to have to keep telling yourself to breathe in and breathe out, all the while you're telling your heart to beat, all the while you're telling your stomach and every other part of your digestive system to work, on top of everything else. And have you ever wondered why in certain movements, such as jumping, you aren't able to change the way you jump while you're in the air, even though you might be telling yourself to, such as jumping higher? While on other times, you'll be able to stop your movement or change it in the mid of the motion. This is because we have 2 different feedback systems that control our movement. There's an open loop control system and a closed loop control system. An open loop control system acts completely on the basis of input. The output, which is our sensory information coming in, has no effect on the control actions. This means that while completing a movement, any sensory information we take in will not affect our movement no matter what. Like I said, if you're jumping up a step but realize you didn't jump high enough mid-step, you're going to land down funny no matter how much you tell yourself to get higher. Now, a closed-loop control system looks at the current output and alters it to the desired conditions. This just means that while completing a movement, any sensory information we take in can affect our movement. So take an example of you running on a dirt path and you may not see the rock in front of you. While you're running, you may trip on that little rock, but mid of that run and fall, you catch yourself so you don't trip. You're able to do that because all the sensory information you're taking in is affecting your movement and you're able to stop yourself in time. Now that we've learned a lot in detail about the nervous system and how it functions, let's take that information and understand how we move and why we move certain ways. Turning sensation into movement can be done through the stimuli in the environment activate specialized receptor cells in the peripheral nervous system. Sensory neurons take information from the eyes, ears, nose, tongue, and skin to the brain, using our senses to do so. Motor neurons carry messages away from the brain and back to the rest of the body. This in turn can affect our movements based on how the brain determines it wants us to move. All neurons relay information to each other through a complex system, and it affects the way we think, learn, move, and behave. When one of our sensory neurons pick up information from the world around us, it's going to send that info to the brain to be processed. And when the brain processes that information, it decides if that information is a threat, whether it's going to affect how we run, if we need to avoid it. The brain's going to send out a command to respond to that information. And that command is going to go through to the muscles, and the muscles are going to determine how we move our body.